Okay, today's notes and assignment, well, there's really not an assignment, is there? These are just notes, okay? This piece of paper is strictly notes for hopefully to increase your understanding about these points of concurrency and what we need to do in order to graph them, and especially here in our algebra problems, right? Figuring out what we need to do to find the circumcenter. Okay, your assignment today is the Schoology. It's a vocabulary quiz. It's timed. Once again, it's timed. So sit down with exactly 20 minutes of uninterrupted time so you can do good on that. Okay, just keep that in mind. It is timed. And I think you get 2 chances, maybe 1, so pay attention to what you're doing. It's open notes, so have your notes. All right, number 1 says, approximately where is the circumcenter of the triangle formed by these 3 points? Okay, so the circumcenter. If I want to find the circumcenter, what segments do I need to draw? Good, I'm glad that you're all awake. The perpendicular bisectors. So I need to construct the perpendicular bisectors if I am going to find the circumcenter. Okay, so I need to draw the perpendicular bisectors if I am going to draw the circumcenter. So let's first plot these 3 points on your triangle so that we have something to work with. Now that we have our triangle, let's figure out what the bisector, right? If it's the perpendicular bisector, what does that mean for the sides of your triangle? Well, bisector means cut in half. So the first thing we have to do is figure out where the middle of each of our sides are. Where is the middle of each of your sides? If it's the perpendicular bisector, we have to find the middle. So we're going to find the middle by counting. So let's look at AC. How long is AC? That's 1, 2, 3, 4, 5, 6, 7, 8. AC is 8 units long. Where is the middle of 8? At 4. So there is the midpoint of side AC. And now this one is, we're counting, want to count diagonals? Or shall we count triangles? Let's count triangles. Okay, so let's make a triangle. Right, we have to go 1, 2, 3, 4, 5, 6, 7, 8 to the right. And 1, 2, 3, 4 up. Right, because that's the triangle here that we make. So if we have an 8 to the right, 4 up triangle, what's the middle of 8 right and 4 up? Hopefully you know that would be 4 right, because half of 8 is 4, and 2 up. So 4 over 2 up gets me right there. There is the middle of side BC. Okay, that's the midpoint. That is exactly in the middle. And you do the same thing for your top triangle, which is also 8 over 4 down. So you go 4 right and 2 down, and you find the midpoints. So we need to find the midpoint of each of our sides if we are to make the perpendicular bisector. Now that we have the middle, let's work on the perpendicular part. So what does it mean to be perpendicular? At 90-degree angles, okay? And since we have a graph, how do we know if things are perpendicular? From Algebra 1, you would look at their slope. Okay, the slopes of the lines. That's how we know if something is parallel. Parallel lines have the same exact slope. And what about perpendicular lines? They have negative reciprocal slopes, or opposite reciprocal, if that's what your teacher said. Negative reciprocal slopes. So let's look at some of our slopes. Let's look at AC. What is the slope of line AC? Yeah, I know this is really difficult. You haven't done algebra for decades, it seems like, and you're only a decade and a half old. It's been decades. Well, this slope is a vertical line, so a vertical line has a slope that is undefined. So that vertical line has an undefined slope, a vertical. So what is perpendicular to a vertical line? A horizontal line, of course. A horizontal line is perpendicular to a vertical line. Okay, and a horizontal line has 0 slope. So this would be the perpendicular bisector for side AC. Right? It is 90 degrees, and it is in the middle because our slopes are negative reciprocals. So now let's look at side CB, right? Side CB right here. What is the slope of this line? Well, it's up 1 over 2, up 1 over 2, up 1 over 2, right? This is how you find the slope, by simply counting the rise over the run. So this has a slope of 1/2. Up 1 over 2. CB has a slope of 1/2, right? This is algebra. We are counting the rise, the y values up, and the x values to the right, and we are writing them in a fraction form like you do for all slopes. Rise over run. So what slope is perpendicular to 1/2? -2. So we reciprocate, which means you put the 2 on top of the 1 and you make it negative. So our perpendicular line has a slope of -2. So we go to your midpoint, which is this dot right here, right? This is your midpoint. And you go up 2 units and 1 unit to the left. Up 2 units, 1 unit left. That's how we get a -2 slope. You go up and left. So this is the perpendicular bisector of side CB. It has a negative reciprocal slope, and it goes through the middle. So we can do a similar thing with this other one. This slope is down 1, right 2, down 1, right 2, down 1, right 2. Okay, we are counting to figure out what the slope is. So the slope is -1/2. Down 1, right 2 is the slope of line AB. So what is the slope perpendicular to -1/2? +2 over 1. Now, +2 over 1 is up 2 and right 1 units, but that's going farther away from my triangle, so that's not really helping me. So up and right is a positive. Also, down and left is a positive slope. So this is the perpendicular bisector line of side AB. So our answer is, where do all 3 of these points meet? Hopefully you know that's here. This is the intersection of all 3 of those lines. And you probably can actually figure it out once you have 2 lines. Right? Because the 3rd line has to intersect also. So what is this coordinate points? 1 in the x and 2 in the y. So the circumcenter of this triangle is at the point 1, 2. Okay, so now we're throwing in a crap ton of algebra into your geometrical processes. Okay, all right, pretty good stuff. Let's look at number 2. Approximately, where is the centroid? Where is the centroid? So if I want to find the centroid, what lines do I have to graph? I have to graph the medians. The centroid is the point of concurrency of the medians. The centroid is the point, the medians are the lines. Okay, so let's graph our triangle. A is -1, 2, and B is 7, 0, and C is -3 and -4. So there's our triangle. So if we want to graph the median, what information do we need to know? We need to know the midpoint. The median is a line that goes from your vertex to the midpoint of the opposite side. So all we need to do is plot the midpoints. So let's get to counting so that we can figure out where the midpoints of each of your sides are. Right? Where are the midpoints? So let's count. AC, let's make a triangle for AC. You go up 1, 2, 3, 4, 5, 6, and over 2. Okay, so this is up 6 over 2 triangle. So the midpoint is up 3 over 1. So here is the midpoint of side AC. Okay, do a similar thing for side AB. 1, 2, 3, 4, 5, 6, 7, 8 units over and 2 down. So the midpoint is 4 and 1. So go back to your point A, go 4 units to the right, and then 1 unit down, and that's the middle. That's the middle of that line. And then the same thing for CB. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4. So we're going to go over 5 and up 2 in order to find the midpoint. Okay, so we find the midpoints by counting triangles. We count the horizontal distance and the vertical distance for your triangles. And then, since it's in the middle, you chop each of those in half, and that can tell you the triangle that you use to make your midpoints. Okay, you can, of course, use the formula, right? x1 plus x2 divided by 2, and y1 plus y2 divided by 2, if you want each of your endpoints. Okay, so there are multiple algebraic ways, and then there's some graphical ways. So now that we have the midpoints, we just need to connect your vertex to that midpoint and make as straight of a line as you can. So if you have a ruler or a straight edge or the side of your phone, use something that is perfectly straight and trace so that you get as close as you possibly can to that intersection point, right? They're all supposed to go through the same point. And this one is not perfect. You would not believe how incredibly difficult it is to actually find a perfect centroid from 3 points. It is not easy. So this one is, of course, not a pretty point, right? It's not perfectly at a dot. It's not a nice x and a y. So it says approximately. So approximately, how far to the right have we gone? Right, point something, 0.75, 0.8, 0.6, maybe even 0.5 if that's what your graph looks like, but it's not quite 1 unit to the right. And then how far down has it gone? Who knows? Maybe 1/2, maybe 2/3, maybe whatever. I'm not exactly sure where, but I know it's less than 1. So I'm going to estimate it as negative 0.5 for my y and positive 0.8 for my x. So in order to graph the centroid, we need to be able to graph the medians. Okay? And in order to graph the circumcenter, we have to graph the perpendicular bisectors. Now number 3 just says, what is the equation of the altitude from point A in this triangle? Okay, so let's first graph our triangle, and then we'll come back and talk about how we find the equation for the altitude. Okay, if we're trying to graph an altitude, right, think about where an altitude starts and how an altitude intersects the opposite side. So from A, that means this is the vertex that we're going to be using, right? This is our vertex. This is point A. This is the altitude where we're going to start drawing it from. Okay, and how does it intersect the opposite side? The altitude intersects the opposite side in a 90-degree angle, right? Perpendicularly. Perpendicularly. It needs to strike over here at a perpendicular. So what do I know about algebra if my lines are perpendicular? The slopes are negative reciprocals. Okay? The slope of the line from point A has to be the negative reciprocal of the slope of the line that it is intersecting. Right? I want perpendicular to be here. In the up above problem, right, we had the perpendicular from the middle. We started here and we drew the graph or the line that was perpendicular. Okay, so we looked at the slope and then the line started in the middle. Well, in this case, when I'm doing the altitude, I need to start my line at this point. It's from the vertex perpendicular. I don't know where along this line it's going to strike. I don't know. And there's really no way that I can calculate it. So I'm going to start here, and I'm going to do the slope of the line until I get to CB. So let's first talk about what is the slope of line CB. Okay, up 1 over 2. Up 1 over 2. Right, and if you can't do that, just make a whole entire triangle. This goes up 4 over 8. Okay, so the whole entire triangle from C to B is up 4 over 8. So that has a slope of 1/2, right? 4 over 8 reduces to 1/2. So CB has a slope of 1/2. What's the negative reciprocal of 1/2? -2 over 1. Okay? The negative reciprocal of 1/2 is -2 over 1. So from point A, I am going to do a -2 slope. That means I go up 2 units and left 1 unit. Up 2 units, left 1. Up 2, left 1. Up 2, left 1. Okay, and I do that slope until I pass my line. Okay, I pass my line of CB. So I have a -2 slope as the line of my altitude, right? That's the slope of my altitude is -2. So going back to Algebra 1, if I want to write an equation of a line, y equals mx plus b, that's the equation of a line. What 2 things do I have to know? I have to know the slope, and I have to know the y-intercept. B represents the y-intercept. That's where the graph crosses the x-axis, and m is the slope. Well, do I know the slope? Sure do. The slope is -2 over 1, which we don't even have to write over 1. That's just ridiculous. Nobody writes divided by 1. So the slope is -2 plus, what is the y-intercept? Where does this graph cross the y-axis? At +3. This graph crosses the y-axis at +3 because I plotted it and I figured it out. So this is the equation of the line of the altitude from point A. -2x plus 3. It has the slope of our line and it has the y-intercept of our line. Okay? So these are some algebra problems, right? It was on a grid, so we have all this algebra that we can do with this geometric concept of altitudes and perpendicular bisectors and medians and so forth. Okay? So let's jump down and do number 6 for a second, because this is an algebra problem that we haven't talked about much. So let's talk about it for a minute. D is the centroid. Right? What lines do the centroid go with? The centroid is the point of concurrency of the medians. Okay, so this was one of your properties, right? One of the properties of the centroid is that it cuts your median proportionally. So from yesterday, if you remember, how much longer is it from the centroid to the vertex than from the centroid to the midpoint? Do you remember what that was from yesterday? Twice as long, right? This much from B to D is twice as long as, whoa, that's not right. Twice as long as this much from D to E. Okay? The length from B to D is twice as long as D to B. Okay? From your centroid, which is point D, to your vertex is 2 times as long as from your centroid to your midpoint. So we can set up the equation, 3x minus 2. Nope, that's not right. So which one is longer? That's the question. Which one of these segments is longer? The 5x minus 2. And how much longer is 5x plus 6 than the other one? 2 times as long. Right? So in this case, right, and I know this isn't very easy to see because I just wrote off there and it's black and it's hard to see on this, but minus 2 goes there. So this much is x, right? That is x. And the rest of this is twice as long as that one. Okay? So I know it looks crazy in your formula, but this is 2x, right? This much equals twice the x value. So x in this case is an equation that is 3x minus 2. So the top length equals 2 of 3x minus 2s. So now let's do some algebra and see what we can do to solve this for x. Distribute 6x minus 4, and we distribute in there. Okay, now let's do some algebra. We got to get our x's on the same side. Let's bring our 5x over to this side because 6 is bigger than 5. So 6x minus 5x is 1x. And then let's bring the 4 over to this side by adding. So what's 6 plus 4? 10. Oh, and x equals 10. I don't have to do anything else except for x equals 10. So now it says, what is the length of BE? So let's plug your x back in. What is 3 times 10 minus 2? Excellent. 28. 3 times 10 is 30. 30 minus 2 is 28. Okay, and what is 5 times 10 plus 6? 56. Is 56 twice 28? Yes, it is, of course. So then what is the entire length from B to E? 56 plus 28. So BE equals 56 plus 28, which has a 4 in it, carry the 1. Is that 84? Yeah, 84. So BE is 84 units long. Okay, so we can put these on grids, right? We can put it on an XY coordinate and give you the corners of your triangles, and you can do different algebraic things with our geometric concepts. Okay, so you don't have to do number 4 or 5. I think on the other video they're done for you. So if you want to look at 4 and 5, you can do that. If you want to check them out for additional, right, if you want to try and see if you know what you're doing, do 4 and 5. And then go check the key on Schoology. But for today, your assignment is a vocabulary quote-unquote quiz. Right? It is timed. It is still open notes. So make sure that you have adequate time to do it without any distractions so that you can get another excellent grade added to your already excellent grades. Okay? All right. That's all for me today. Goodbye.